1. Project Overview. The project is located at the KM 68.175 Canal Kilometric near the ENR kilometric position 123.350 of the Benha Port Said Lane between El Ismailia and El Kantara East stations. The project includes the upgrading of El Ferdaan Bridge over El Suez Canal, the construction of a new bridge over New Suez Canal, the subgrade between the new and the existing bridge, the about 2,000 metre long subgrade on the east bank of New Suez Canal, 3,509 metres square new auxiliary bridge buildings, and the relocation of 2 existing roads beside the canal. 2. Construction of a double swing rail bridge over the New Suez Canal. 1. Bridge Superstructure Program. The whole bridge consists of 2 double cantilever swing girders. For single double cantilever swing girder, the main span cantilever is 170 meters long and the side span cantilever is 150 meters long. The whole bridge is
640
meters long. The facade structure of main girder is the same with the old bridge, adopting high steel truss structure. In view of the characteristics of the railway load acting on the structure, the bridge deck system is of longitudinal traverse girder structure with simple load transferring mechanism. 2. Rotation and locking of swing girder. The opening and closing of the bridge can be automatically completed with manual on-site operations or completed through the network remote control. Bridge closure includes 5 actions. 1. Release of bridge end locking device and 90-degree pier and abutment. Locking motor reducer rotates to drive the horizontal motion from trapezoidal thread to locking bolt to release the plug-in. 2. Rotation of rotary drive system in closure direction. Driving motor reducer drives the gear ring to realize the swinging and closure of the whole bridge through the roller rolling. Heavy pressure-proof rubber is set between the upper track and the upper support girder to reduce the unevenness of roller wheel pressure. In order to meet the speed difference of roller wheels sliding inside and outside the track circle and reduce the vibration caused by uneven rotation speed, the wheel is divided into 2 parts, and the middle is set with gap and provided with a spacer. 3. Bridge end locking device and bridge end locking. Locking motor reducer rotates to drive the horizontal motion from trapezoidal thread to locking bolt to lock the plug pin. 4. Locking of cord locking device. Driving motor drives the trapezoidal nut rotation through the transmission system to push the screw to drive the sliding support to move forward and make the cylinder shear pin inserted and locked. 5. Locking of rail locking device. The rail locking motor reducer drives the switch rail to horizontally move it to its position through rack and pinion mechanism and drives the locking spring and the rail steel plate to move their positions. 2 trains run in opposite direction at 60 km per hour. The bridge opening and closing actions are exactly the opposite. Release the rail locking device. Release the cord locking device. Release the bridge end locking device. Rotate the rotary drive system in opening direction. Lock the bridge end locking device and 90-degree pier and abutment. 3. Upgrading of the double swing rail bridge over Old Suez Canal. The rail bridge across Old Suez Canal carries 1-track railway and 2-lane road. After upgrading, the old bridge will carry 2-track railway as required, so it is necessary to upgrade the decking, interlocking system and main girder. For the deck system, 1 longitudinal girder is added respectively on both sides of the longitudinal girder of original track, and the original single-track railway is replaced by 2-track railway. For the main girder, main tower and stay cable are arranged above the main girder to ensure the structural safety under the action of 2-track railway. The new main tower is welded to the top of the original truss girder, and 2 stay cables are arranged on both sides. The stay cables continuously pass the main tower and are supported on the main tower by the saddle. Both ends of the stay cable are anchored at the top cord nodes of the main girder. For the rotary and interlocking systems, replace the mid-span cord locking device, rail locking device, bridge end locking device, and components of brake gears and rings in the rotary system, which are consistent with those of the new bridge. 4. Instruction to construction program. The lower pile foundation of the bridge is constructed with rotary drilling rig. The cushion cap is constructed with steel sheet pile cofferdam. The cushion gap turntable is installed in sections by crawler crane, and the top steel truss is processed by the professional manufacturer and transported by sea to the construction site. Temporary support frame is erected for installing steel truss girders with 350T crawler train, adhering to the advanced concepts of employing new technologies, new design, new materials, and new processes. We will be committed to creating excellent projects to satisfy the employers with high quality services. If giving us a chance, we will return you a miracle.